It takes John 4.5 hours to paddle his boat 18 miles upstream. He then turns around and paddles 18 miles downstream in 3 hours. What is the rate of the current? What is John's paddling rate in still water? So this is a system of equations problem. And the best way to approach this problem, really any word problem, is just to translate each sentence one at a time. So let's look at the first sentence. It takes John 4.5 hours to paddle his boat 18 miles upstream. So we will say R sub upstream is equal to 4.5. Actually, we'll do it the other way. Let's do it, because normally you do things distance per time. So we'll say 18 miles per 4.5 hours. And let's use our calculator to see what that is. So 18.5, I'm sorry, 18 divided by 4.5, that equals 4. 4 miles per hour. Okay, and then he turns around and he paddles 18 miles downstream in 3 hours. So that's another rate. So we'll say R sub D is equal to 18 miles, same distance, but now he's doing a little bit faster, per 3 hours. And that is equal to 18 divided by 3 is 6. So that is 6 miles per hour. And that makes sense because you're going upstream, and if there's a current moving against you, you're going to go a little slower, and if there's a current going with you, then your rate of speed is going to be a little bit faster. So let's say you're going, let's say this is the speed of just paddling. We'll call this R sub the boat. And this is if you're in still water. Well, if you have the rate of the current moving with you, and that's kind of helping you along, R sub C. Well, if you add these two things together, then you're going to get the downstream rate, which is this guy. So R sub D is equal to the rate of the boat in still water plus the rate of the current. And let's look at the other scenario. So if you have the rate of a boat, but then there's a current moving against you, that's the rate of the current. Well, these are going to subtract against each other, so then the rate upstream is going to be the rate of the boat minus the rate of the current. Okay, so what we can do now is we can substitute in our values, and so the rate downstream is equal to 6. So we can look at this equation right here first, and so we're going to say 6 is equal to, we're substituting for R sub D, is equal to R sub B plus R sub C. So again, this is R sub B is the rate of the boat in still water, which the problem asked for. And then the second equation here, so this is equation 1, and then this guy is equation 2. And so R sub U is 4 miles per hour, so we can just substitute that in. 4 is equal to R sub B minus R sub C. And a lot of times, students will look at this and say, well, that looks weird, maybe because of the subnotations. But if I was to show you the same problem and I said x plus y is equal to 6, and then I said x minus y is equal to 4, and I asked the students to solve that, they'd be like, oh, that's easy. It's just a system of equations, and the way it's set up, you can probably use elimination, which is exactly what you would do. But then when you look at this, you just need to realize it's the same thing. Well, instead of x and y, you have R sub B and R sub C. So we can solve it with the same methodology that we use in this scenario. So let's just go ahead and use elimination. Well, it's already set up very nicely. So we can just add up the r sub c and the negative r sub c, and that ends up being 0. R sub b plus r sub b is just 2 r sub b. And then this is equal to 10. So we divide 2 off both sides. And then finally we get r sub b. This is going to cross off. 10 divided by 2 is 5. That equals 5 miles per hour. And that's how fast the boat would be going if it was moving in still water. And that makes sense because when we're going upstream, we're moving a little slower than that. And when we're doing when we're looking at it in the downstream, the current is helping us, then you're going a little bit faster. So that makes sense. So now we can actually find out the rate of the current. And again, we go back to these two equations, and it really doesn't matter which equation you use, just like when you're doing a system of equations problem. So we can just we'll just take the first one. So we'll say r sub d is equal to r sub b plus r sub c, and this time we're solving for this variable. Well, r sub d, again, we know is 6. And then we just solved for r sub b, and that's 5, so we can substitute those values in. So 6 is equal to 5 plus r sub c. Now the goal of the math sentence is just to get the variable by itself, in this case r sub c. So you subtract both sides by 5, and then you get r sub c is equal to 1. So r sub c is equal to 1 miles per hour.